Welcome, my dear students in Prep 1. Today we will continue parallelism. We will talk about some facts. At first, the perpendicular to coplanar parallel straight lines is perpendicular to the other. It means that if we have a straight line L, for example, this straight line is perpendicular to AB, a straight line AB. Then this straight line will be perpendicular to any other line parallel to AB. Again, if we have a straight line L perpendicular to a straight line AB, in this case, this line L will be perpendicular to any other straight line parallel to AB. And vice versa, if two coplanar straight lines are perpendicular to a third, then the two straight lines will be parallel. Okay, if the straight line AB and the straight line CD, for example, both are perpendicular to the straight line L, so the two straight lines AB and CD will be parallel. The second fact, if the two straight lines are parallel to a third, then these two straight lines are parallel. Like here, for example, the straight line AB parallel to the straight line CD, and we draw EF parallel to CD. So in this case, EF will be also parallel to AB. Another fact, if a parallel straight lines, like here for example, L1, L2, L3, L4, they are parallel straight lines, divides a straight line into segments. Divides the straight line M1 into segments which are equal in length. It means that AB, the length of AB equals to the length of BC equals to the length of CD. Then they divide any other straight line, for example M2, into a segments of equal length. So AB will be equal to BC and equal to CD, and in the same time EF equals to FG equals to GF, but it's not necessary to be equal. The parts in M2 is not equal to the parts of M1, but they are equal to each other. Okay, so for example, EF doesn't equal to AB, but EF equals to FG equals to GH. Let's take this exercise. Here we have parallel straight lines, and here a straight line divides, or the parallel straight lines here divides this straight line into line segments equal in length. We have the same sign here and here. So XY equals to XZ. So AC will be equal in length to CB. It means AB will be 3 plus 3, which is 6. Here, for example, we have equal straight lines AY and YX and XC. So here the three straight lines here are parallel. So here also AD will be equals to DH equals to HB. So the 12 will be divided equally into 3 parts. So each part is 4 centimeters. So BH will be 4 centimeters. To calculate the perimeter of the triangle ADY, this is 4 centimeters and 3 and 2. So I'll add the length of the sides to get 9 centimeters. Here, for example, in each of the following, Y is the straight line AB parallel to the straight line CD. The first one, we have two equal in measure angles, and they are alternate angles, so the two straight lines should be parallel. So if we found two alternate angles which are equal in measure, it means that the two straight lines here are parallel. The next one, here we have this angle equals to 54 because they are vertically opposite, and 54, here we have two interior angles. If you add 54 plus 126, you will get 180. So the two angles here, the two interior angles and on the same side of the transversal are supplement. So the two straight lines are parallel. AB parallel to CD. Here we have two parallel lines, AC and DE. So the angle here, the interior angle, 125. Here we have another angle. It will be supplement to 125. So this angle will be 180 minus 125. It will be 55 degrees. So here we have 55. And here we have alternate angle and equal in measure to 55. Okay, that means the two straight lines AB and CD are parallel. Okay, so we said that two straight lines are parallel if we found any two alternate angles equal in measure, or any two corresponding angles equal in measure, or any two interior angles supplement. In this case, we said that the two straight lines are parallel. Okay, that's all about our session today. Next session in geometry, we will take or we'll talk about geometric construction. Thank you very much for watching. See you next session.